Welcome to October's Leetcode challenge. Today's problem is 132 pattern. Given an array of integers, a 132 pattern is a subsequence of three integers such that they're in order and I is less than k and is less than j. Really, that's all just a way of saying that we want to find a low to high to somewhere in the middle sort of pattern in our array. So we return a true if we can find this 132 pattern, otherwise return a false. So we can see here with 1, 2, 3, 4, obviously that pattern doesn't exist. But with 3, 1, 4, 2, this one, 1, 4, and 2 in the middle, that exists. Now the straightforward method is to just use a nested for loop, right? We can start with the outer loop of starting with one index number, check all the rest to see if it's greater than this current number, and then check in the third nested loop, check to find one that's in between these two. And that would be an n to the third power solution. That's very easy, but it's going to reach a time limit exception. Now they go through some more examples, kind of building this upon the brute force and a better brute force, going on to binary search. But I'm just going to go into the optimal method, just because it would take forever for me to explain everything. And the optimal method is pretty interesting because it's kind of hard to really wrap my head around. So say that we had, let's think, an example like 1, 2, 3, 4, and then suddenly jumps down to -4, -3, -2, -1, something like that. Now, if we were to find like an increasing pattern like this, you might think, well, let's just store the minimum, store the maximum. And as soon as we find a number that's in between the minimum and maximum, we could return true, right? But no, we can't, because what if this happens? Suddenly we have this new negative low point, but our high point remains the same, right? So that's not going to work, because if this suddenly changes to the minimum and our maximum still remains 4, then if we had the number like -3 here, then we say, oh yeah, we found this pattern, but we actually haven't. We started at the high to the low to something in the middle. So the only way you would be able to kind of keep track of this if we had multiple mid and high points. And that's just going to become this exponential solution. So we really can't do that. But what if we went backwards? Now, something interesting happens when we go backward. When we go backwards, what we're looking for is a decreasing pattern, right? And these are increasing. So let's just kind of flip that and say, what if it's decreasing? And these were like negative. Well, if we were decreasing, kind of what happens is, when we find this decreasing pattern, all we're looking for then is to find not something in the middle, but just something that's less than the greatest third point that we found so far. So here, if it's like all decreasing, get 1, 2, 3. 3 is our greatest third point, right? So all we need to do, we can store everything in the middle here in the stack, have this third number as kind of the variable that we check for, and then if we just find one that's less than that, like -4, then we found our pattern, and we have -4 all the way to 4 to 3, and all these two become, the rest become irrelevant. If they're decreasing, we just want to find the maximum. And you might think, well, don't we have to like worry about these weird -1s occurring? But if you think about it, like say that this became 40 suddenly, it just went out of range, and this became, let's see, like 30, 20. Oh, these aren't decreasing. Something like this, it just suddenly just went out of range like this. Like, actually then these all become decreasing order like this. So again, if this were to happen, we can just store the greatest number that we've seen so far in this decreasing pattern. As soon as we find one that's less than that, like say we found 20, then we've found our pattern, right? 2, 4, 3, that's the pattern. So that's pretty interesting. Like, okay, what we'll have to do is store, let's say, our length of nums, and we'll have something called the stack, as well as our third variable. And the stack will just be a list, and we'll have this third variable be float of the lowest infinite, because our base condition is going to be where we find a number that's less than the third variable, right? So we can start with the lowest number possible. Now for I in range of n minus 1 minus 1 minus 1, because we want to go backwards. First thing we'll check to say is, hey, is nums less than our third? And if it is, yes, return true. Now we're going to have a while loop here. And while there's a stack, and the stack last one on our stack is less than our current number, we want to pop that off. Why? Because we want to store this third variable as the highest one possible. Right, so we're just going to pop that off our stack. And finally, we need to add this middle one into the stack, right? So stack.append this nums.I. So if we get through this whole loop and we can't find anything, then we should return a false. And that should be it. Let me make sure I didn't make any typos. That's false. Let's go and submit that. And there we go. So I realized this looks, oh wow, so simple. But no, this solution was really hard. Not one I came up with. And honestly, even understanding it is taking me a while. I don't still completely understand why this works in reverse, but why it doesn't work in front. But it's definitely got something to do with the fact that the third one needs to be in the middle, while if we were to go forward, we have to check for like these low and high ranges. All right, so thanks for watching my channel, and remember, do not trust me, I know nothing.